All right, good morning. Today we're going to be talking about whether or not something is a function in many different formats. First format we're going to look at is a mapping diagram. But before we get that, let's talk about what does it mean to be a function. All right, think of a function like a machine, any kind of machine, like an oven. And let's say you put something into the oven, like a pizza. You turn it on, you close the lid, or you close the door, and you come back and check on it in 10 minutes, and you open it up, and you expect to find a cooked pizza. What happens if you open it up and it was a pizza? It wasn't quite done. You walked away and you came back and you opened it up again and it was now a turkey sandwich. That'd be weird. It was supposed to be a pizza. So you put in pizza and for some reason you open it and it wasn't pizza anymore. That's kind of what we're talking about with a function. We put something in and we are always expecting to get the same thing out. And if that doesn't happen, then it doesn't work. We're looking for that. We're looking for a broken function. All right, so we just kind of identify what makes something broken. All right, so here's what makes something broken. Something is broken if you put the same number in, you put pizza in the oven, and the first time you open the oven and you get a cooked pizza out. It looks a little different than when you put it in. It looks cooked now. But the second time you did it, you checked it, and you had a different answer. It wasn't pizza anymore. So again, all we're looking for, it's very, very simple. The only thing we're looking for are repeated inputs. If we have repeated numbers, all right, repeated inputs, all right, the idea is that they must have the same output. So if we have repeated input numbers, I put pizza dough and cheese and crust and all that into the oven, I am expecting to get out a cooked pizza. All right, so again, this is how it works. So if we have an input number that is used twice and has different answers, that would be not a function. Again, that's the only thing we're looking for. Now, sometimes they draw these mapping diagrams kind of weird. So let me show you what I'm talking about. Sometimes they have a list of numbers over here like 0, 1, and 2. And a list of numbers over here like 10 and 15 and 20. And then they draw these little arrows to show what goes with what. 0 goes with 10. 1 goes with 5. 2 goes with 20. As long as there are no repeat input numbers with different output answers, then this is fine. All right, so that would be an example of everything being fine. Well, what about this? What if I had this, and then this, and then this one? Is that okay? Well, again, the only thing you're looking for are repeated input numbers. Do I have any repeated numbers? Well, there's one arrow coming from a 0, one arrow coming from a 1, and one arrow coming from a 2. Those are not repeated input numbers. So this is okay. This is fine. I don't care at all what the output numbers are looking like. That doesn't really matter. All right, so let's take a look at one more possibility. All right, what happens if we have this? Again, what I'm looking for are repeated inputs, and I have it right here. 2 arrows coming from the 0. Now, if those arrows are pointing at the same number, then everything's fine. But if those arrows are going to 2 different answers, then that's bad. Again, you're not looking very hard here. You're only looking for one special thing. If you don't find that special thing, everything's fine. If you find that one special thing, it blows up the whole thing and it's bad. So the one special thing we're looking for is what I've got circled right here. One input number going to 2 different outputs. Again, that means you put pizza stuff in the oven, and the first time you get pizza, and the next time you put pizza stuff in the oven and it makes cake. That's weird. That's broken. Something's wrong. All right, let's look at another one. A table. All right, and we're looking for the same exact thing in the table as we were in the mapping diagram. All right, we are looking for repeated x's. If we don't have any repeated x's, then everything is fine. It doesn't even matter what goes in the y column. If there's no repeated x's, everything is good. But if we did have a repeated x, like right here, all right, repeated x's, they must have the same output answer. That means if they're both the same answer, everything's still fine. And again, these ones over here didn't matter. They weren't repeated x's. So if they're the same, it's fine. The only time it's bad is if those are different. If you have repeated x's with different answers, that's bad. What about from a graph? All right, from a graph, what we're looking for is the vertical line test. All right, it's looking for the same thing. It's looking for repeated x's with different answers, but it uses a picture instead. So if I have a line that looks like this, and I draw every possible vertical line I can think of, as long as it only hits the blue line once, everything's okay. But if I were to have a picture that looks like this, and the line hits twice at the same time, that's bad. That's the same thing. That's a repeated x with two different answers, but this is what it looks like in a picture. All right, so let's do a couple of examples. All right, so first example, we're looking at the mapping diagram. And again, the only thing I'm looking for is this column. Are there any repeat numbers? For example, the 1 only has one arrow. It's good. I don't care what it goes to. It's good. The 3, only one arrow. It's good. The 5, one arrow. It's good. The 7, one arrow. It's good. So yes, it is a function. The next one. I look at the 3, it's got one arrow, it's good. I look at the 1, it's got one arrow, that's good. Now the 0 has two arrows. If they're both pointing to the same number, then we're still okay. But if it's pointing to two different numbers, which it is, then this is bad, not a function. Now let's look at the table. Again, I'm only looking here. If I don't have any repeats, then I'm fine. -5, -3, -1, 1, 3, 5. Okay, no repeats. That's okay. Yes. Whoops, I can't even spell yes. So yes, that's a function. All right, now the next one. All I'm looking for are repeats in this column, and I have two sets of them. Now, if they have the same answers, I'm good. But this one up here already has different answers. I already know this is not a function. It also happened down here. It happened twice in that problem. All right. Last but not least, let's look at graphs. All right, same thing. If I draw a vertical line, and that vertical line can hit the picture twice, then no, not a function. If I'm drawing vertical lines and they only hit the graph once, then that's good. That's a function. All right, so it's not hard work, but it's definitely a lot of information. So you might have to watch this a second time or go back through it if you need to. All right, good luck today.